Oh, Matt gave us a pretty good sense of what's happening around us, the fourth industrial revolution. We as human beings have always built tools. It's that tool building capacity of ours that really takes us forward. And one theme you'll have to notice in all of this tool building that we do is we move through ages, Iron Age, Stone Age, and the last one of it is the industrial or the information age. The most important thing about this is that it has gone through, like Matt mentioned, the water and steam-based, subsequently to the production pipeline, subsequently to oil-based, and finally telecommunication. Each one of these things, the important thing is motion. Only when you move stuff, things happen. First, we learned to move through the steam engine. Where steam engines could not go, we used sort of the oil to take us far. And the production pipeline really revolutionized how we produce goods. And finally, telecommunications, which is all about, in one sense, beam me up, Scotty. So that's what's really, it's about when you talk about an age, it's about basically a society going through what they call as creative destruction. And out comes a new way of life. Of course, new business models and stuff like that subsist that. So that's what we're actually going through. And like I said, what really sets us apart is our ability to build new tools. And I'll talk to you about the tool we are building here that we believe will revolutionize how we sort of conduct business and how we actually live in this digital world. So let me begin at the beginning, which is about my journey here at Couchbase, what motivated me to come here and give you a personal view of this whole thing. But let me assure you, I will not be gracious enough like Matt to share another mother-in-law story. It'll be sort of a little bit more on the professional end of things. Why did I actually start here was back in the day, it's almost good 8-10 years ago, what we started to notice is that when you go look at your enterprise application and then you start using the consumer-facing application, the delta was the age of the enterprise application was telling. I mean, if you were to use your HRIS system or your expense reporting system, it'll take forever because it was doing what we used to call server round trips for every click you're doing. Versus if you went to a Facebook or a Google or any of these consumer-oriented applications, things were zippy and fast, and you could really sense the difference. If you really truly examine, it was not about a glitzier UI or anything in the middle. It was truly about them changing the game as far as data is concerned, how quickly data could be transported to you in your browsers or your devices. That's what truly transformed. They understood because the volume, variety, and the velocity at which the data was coming to them, they had to solve the problem differently. That's what got me thinking. So if you have to move the needle, we really have to build something good, something different, something that is actually not just yet another of the same. And that was the opportunity that Couchbase actually presented. It had the bones of something that could be very different. It had some phenomenal, very clean architectures. But that's only one part of it. The second part is the more important one, which is in Couchbase, we had the team of people, the thinkers, who actually have done this, who have done multiple tours of duty, if you will, in all gamuts of enterprise infrastructure and application development. And so here were a set of people with whom you could have a no-look pass and talk about technology at an entirely different level. So those two were some of the main motivations for me. And we all knew that there is a great journey to be sort of undertaken here. But we knew that we had to start with small steps, and we have taken those steps. And I'll walk you through the kinds of decisions and the kinds of discussions we have had to build what we have built today, what you're going to see in the platform. Now, let me talk to you about the kinds of transformation that is actually happening, that has already happened, to which we have to react to. It's about the context of the world that we were living in. What has really happened is that the hardware area has undergone tremendous innovation. Memory is way cheaper than what disks used to be when we had originally built the relational systems. Application development has completely changed. It used to be that there was no object-oriented programming back in the day when you actually started this thing. In the hardware section, I forgot to mention how fast the networks have really gotten. When you really developed those older systems, you couldn't put network in the middle. Now you can. It's reliable and it's faster. The application world has tremendously changed in terms of object-oriented programming, all these Ajaxian models, and the flexibility of the data has really come to fore now, as opposed to the older forms in which we used to consume data, which were much more rigid and much more homogeneous. That's what has changed. And finally, the data and the movement of the data, as in you want to keep that in the cloud or in your data center, that completely changes the game. So it's about the volume at which the data is coming at us, at which we are generating the data. So all these required a sort of a generational, that change required a shift in perspective and develop a platform that addresses the needs of the modern world. And that's what inspired us to build the Couchbase Data Platform. We have taken a sort of polar coordinate look at this, as opposed to the regular Cartesian coordinate, in which you'll typically have rectangles of boxes of architecture. So let me walk you through this from the inside out. We built this with some principles. Let me describe those principles to you. First was memory-centric and network-centric architecture. That's what gives us this shared nothing distributed architecture, which we can leverage the speed of the memory and the network to bring the data to the applications, no longer hitting the disk and becoming that the slowest part of your system becoming the bottleneck. That's what gives us the ability of our key value stores being phenomenally fast. So it's our core competency about moving data and keeping data closest to where the compute is happening. To that, we added this capability or this way of thinking, which we call workload isolation. What does that give us is an ability to run different types of workloads on the same deployment, same set of servers, but it isolates so one doesn't compete with the other. That's what allows us to do phenomenal performance, keep the performance, and not lose it when we add more capabilities into the platform. Our key value store still hums at nanosecond response times, even millions of ops per second. We have our querying capability, which is based on the secondary indexing, and that runs in millisecond response times. And same for our full text search, which is the inverted index, if you will. And then finally, analytics, which we'll bring to fore shortly, but that can done. So basically, the way we describe it is a primary index, secondary index, inverted index, no index, all covered in the same platform. But in the older vertically scaling systems, all these used to compete for the same set of resources. Now, with this workload isolation, we can take them out and independently scale different parts of the system, because what you're independently scaling is network, memory, compute. Now, to this, we have the other philosophy is location-unaware data. As in, you don't need to care where the data is. Is it in the cloud? Is it on the edge? Where is it? It should not be. It should be available at your point of interaction. And that we achieve by building replication into the core architecture of ours. So that allows us to move data for geolocation, for geofencing, for bringing data closer to your end users and customers. That's one side of it. At the same time, we have this mobile solution built, which brings the data to your edge, to your device, in your hand. And this is all accomplished with various technologies. But at the end of the day, you don't have to be worried about where the data is sitting. Is it sitting behind a firewall? Is it in the cloud? Is it on the edge? You can kind of CDN your data in one sense now with this. We also have this other philosophy of deployment unaware. This is when the product really shines. It's actually built for the cloud. the capacity of the cloud is elasticity. That's what it really offers. Pay as you go. When you really say that, what it means is elasticity underneath it. Traditional databases cannot take advantage of this because they are vertically scaling, whereas in this platform, you can take advantage of that. And when I say deployment unaware, you can be on the cloud, can be in a multi-cloud environment, you can be on-prem, can be running this in bare metal or in virtualized containers. All possible. All neatly orchestrated as well. We'll talk about it more later, but that's another capability here. All this is good from the standpoint of running an industrial strength data platform. But the core thing is basically for the developers. What we have really done from that standpoint is to bring the flexibility of JSON and the power of SQL together. That's what gives this platform the unique capacity to be able to be that agile. So at the end of all of this, what do you get out of this platform is the ability to develop in an agile manner and deploy it at any scale, anywhere, be it on the cloud or on the edge or on your data center. Now, I talked to you about the ability to be on the cloud, but actually this cloud is something which is really old news. It's been going on for about 15, 18, maybe 20 years now. And we used to, back in the day, call them ASPs. Anybody knows what ASP stands for? Application Service Provider. Somebody invented this marketing term called cloud, and now we live in this cloud world. But this has existed for a long time. It's really old news. But somehow now is when the movement to the cloud is really happening, but we have to think ahead. It's almost like talking about a post-cloud world. It's a different kind of a PC world, if you will. And that is basically when the edge really comes to fore, because we believe there is more compute at the edge than at the core, and that's what we have to leverage. We're all carrying in our back pockets devices which used to sit in data centers, and we used to have ACs cooling them not that long ago. So that's the compute we have to harness. And what do you do with all that compute? It's meaningless unless you can crunch data. So you have to have the data at the edge that you can actually do something. And the transportation of that data from the in the cloud to the edge is what we already resolved in this platform, which is why I mentioned about the movement of the data is what will really liberate us in the next phase of our evolution. And for the movement of the data, another piece is very important. The data has to become flexible, malleable. And that's another thing that we have achieved by bringing the flexibility of JSON and applying the SQL capability on top of that. So we'll talk more about some of those things. As we keep enhancing this platform, there are major decisions that we have to make. And whenever we want to make a decision, we, among the engineering crowd, talk about how we want to build something. And the thing that comes to our mind is not to get stuck on some concept just because it's been there, that we don't feel that necessity to just follow. And that's dogma. You can get stuck in dogmas versus what you have to really build for is the current context. So context over dogma is typically our general conversation if you have to have a tiebreaker in terms of how we want to sort of move the needle. If you keep talking about dogma, you get stuck. There are a lot of good things. That doesn't mean one has to win over the other. It's not a case of my karma or your dogma. That's not the point. But it is about understanding the good things that are sitting in the dogmatic world and enhancing from there, taking the good things and moving it forward. So let me talk about a few of these areas where we have had to make such choices so that we can move the platform ahead in a quantum leap. The first is you're on NoSQL, so you don't need SQL. This is dangerous. If you start using a marketing slogan and translate that to your corporate philosophy or architectural philosophy, this is where you land. The real thing that when somebody named it NoSQL was just for easy way to understand what this is about. The real problem we really had to solve out there was two things. One was to remove that rigidity of schema. The other was to be able to scale out. That's what brings the cost down. Otherwise, vertically scaling systems were hitting their limits, right? So that's what it was. SQL was never the problem. Underneath it was the problem. So you basically need to keep that tier. In fact, I've heard some of the pioneers in this world actually say the only thing worth keeping about our old relational systems is SQL, because it does have the relationship concept built into it, which is the join. So what does SQL really buy you? Right? It's one of the very first functional languages, which basically lets you say what you want to get done and then leave the how to the platform to take care of it for you. If you don't do it that way, you are left holding the bag about the how, and you have to write tons of lines of code, and you write this in what we call as the client side. The moment you do that, performance drops and all that stuff. The code is still going, as you can see. What you can do in 4 lines in SQL, you'll have to do in like 25, 30 lines. And God forbid if you forgot one of those squiggly braces, right? So you know how we engineers are. We'll say we want to do something new and different. So we could have gone and invented our own query language, another -QL. You know, the entire world is full of such dead languages. But we didn't. We understood the power of this language because there is a great algebra behind this, which is called relational algebra. Actually, it is calculus, so don't think it's some 7th grade algebra. So it's serious complex math involved behind this, which gives you completeness. So you know with SQL, you will not be left up a creek without a paddle. That's why we picked. But then the underneath data model has completely changed. It is no longer the homogeneous Excel spreadsheet like data that you have. It's heterogeneous. It's basically a nested recursive data model. That's what a JSON in true technology terms becomes. So there's a generalized algebra that we had to take and build this query language on top of it, and it is called generally, that area is called N1NF, non-first normal form. And that's why we named the query language NQL, N1QL, a query language for non-first normal form data. That's the world we are living in. We have changed. It's no longer a ledger that wanted to become electronic ledger, which was all rectangle. This is about the data changing shape while on flight. And so we needed a query language that will actually adapt to that. So this query language has those syntax built in, where a certain schema element may not be there, but may be there. So this query language actually works on schema and data. That's the advantage of having putting SQL back to NoSQL. So now you have truly an evolution of a database which has gone from being vertical to horizontal, multidimensionally scaling, which has no schema flexibility, yet it has the same programming capacity. I normally say this is more like a Tesla. The same steering wheel and the same gas pedals, and the same windshield wipers, and the same, we didn't have to reinvent the wheel, thank God. But underneath the covers, everything has changed. No more internal combustion engine, all those accompanying parts. That's what we really achieved with this one. Logically, you have to address this one, right? This is the white elephant or big elephant in the room, so to say. Transactions need ACID. Let's talk about the context before we get into the dogma of this thing. The context when ACID was first proposed, invented, if you will, was mainframe days, late 70s, early 80s, single clock in which the application used to run in that mainframe, single threading into a database. Various modules of the application would share the context, execution context, and then it can basically go talk to the database in the same context. What is the modern context in which you're living? And also, remember, there is no object-oriented programming, there is no World Wide Web, and forget mobile devices, right? That's the context in which ACID was developed. It's a fantastic model. It's theoretically complete, beautiful. All the professors can teach you. All of us, Engineering 101, did this thing, so we all love this thing. And there is a lot of goodness there, still applicable, which we should take and move forward. What is the present context? The present context is of planet scale, where people are looking for, nobody has the patience anymore. So people are looking for nanosecond latencies, and yet, of course, they want the reliability guarantees of a database. This is the world to which we have to sort of adjust to. And in this world, what is the application doing? It is no longer that monolithic application, single threading to a database. An application is a collection of microservices, each microservice having its own persistence and its own KPIs for scaling and performance. if you look at any e-commerce site, you'll basically typically run into an inventory service, an order service, a catalog service, a zip code service, a tax calculation service. This is an anatomy of a new application. And each is an independent service which runs in its own context. The application orchestrates them together and presents to you the look of an application, which is pretty similar to what some of the monolithic applications would look like. But the decomposition of the application is very different. So in this world, what should the response to ACID be? Definitely, atomicity is required. Durability is guaranteed. Without that, you don't need a database. For a database, you better provide durability. But there are now various ways to look at this other two elements of it, because the orchestration is happening at the application tier, not at the database tier. Now, in this context, when you talk about ACID, you also have to remember the fundamental data model has changed. It's no longer an order table with an order item table, and if you bought, let's say, your toothpaste, a toothbrush, and a mouthwash, one order, 3 order items, 2 different tables, 4 inserts. Now you needed different types of ACID semantics for this one. But in this new world, you can keep the order and the order item in one document, one insert. You don't need all those complicated ACID semantics. It's simplified. Yes, there are places where you would need, if you want to keep a customer in an order, that should be a relationship. That's also available in Couchbase. What people have done, our customers have built, is transactional systems on this with the primitives that already exist in Couchbase. We, of course, will enhance the product further to make these semantics that much more easier to consume. But you can build. You need to first fundamentally understand what has truly changed, how you can reshape your data, and how you can achieve most of this stuff in this shared nothing distributed world, which gives you the performance, scale, and reliability, but it gives you ACID in a different form. Single document ACID is already available. Multi-document isolation and some of the other constructs we'll be building as we keep proceeding. But good 80-90% of the use cases can already be addressed with what is available here, because of the foundational nested recursive data model I talked about solves many of this stuff. The last of these dogmas is that people are too protective. Actually, why do so much of the data, when we deal with many of these enterprises, still sit in mainframes? Forget about relational systems. It's because historically people have understood the value of data. It's not something new now. And that's why they put the best money behind those. That's why many of those operational workloads of most mission-critical applications are sitting in mainframes, right? So now we come from that protected world. So the data is always centrally sitting behind some firewall someplace, and you end up accessing that data. So what happens in most of your mobile devices is that the application logic definitely sitting on the device, but the data is still centrally located someplace. You're making REST API calls to those data. Data is not physically available on the device, and you're not taking advantage of the compute capacity at the edge. You're basically wasting a lot of network and storage and moving the data. That adds latency. The circle of death or the forever throbber is nothing to do with a network being slower. It's to do with the fact that getting to that data is that difficult. It's got to jump through so many firewalls and so many other ports that need to be opened and closed and all this sort of magic that you end up with that latency. What you need is for that data to be on the device. Understood, certain data should not sit on the device. For that, you can pay the price of going back. But most of the data that you're actually interacting with, if you really look at it, should be sitting. If you're making a flight reservation, the flight route, the destination, the time, all that information doesn't change that often. That should sit on the device. If you want to figure out, I don't want to show you the inventory or the price, do a web view or connected way of doing that thing. Easily doable. This partitioning of the application is what the next transformation is going to be. Many of the leading enterprises understand that. They work with us. And this has to become more prevalent. So data needs to be on the device as much as possible. Understood, certain data should not be, and you can protect that appropriately. This kind of dynamism is what is required in our sort of next set of applications. So this is the point I was sort of eloquently talking about without hitting the clicker here, is that you need not just the application logic, but also the data to be sitting on the device. Now you'll come to this question, Yeah, I've heard about all this stuff, and you're not the first guys to tell us this. Because many of us have built these solutions with what I call as chewing gum and baling wire. Because many of the stuff exists in a sort of a raw form. You can, of course, take a relational database and put an application, packaged software applications. I've built some of these in the past, which can do mobile and which can do sync, and you can put another little relational database on the device side. The moment you put 3 joins, that thing is over. So it has been sort of built so far, but it has never been in one platform. You've always had to use mobile backend as a service, some other service, integration in platforms to put these all together. Every time you put another connector in the middle, it just becomes latency is the bane of this whole thing. By fusing all this in one platform, you get that 2 major advantages. One is speed, other is consistency. So you don't have to keep copying data from one system to the other and then worried about when that change happens, how do I move this? We are removing a lot of connectors. It's like we are tripping over our own connector wires. That's what goes away in this platform. So it's about that shared nothing distributed architecture, that workload isolation, that location unaware, the deployment unaware, that semi-structured data and the query language, the synchronization, the replication, all in one place, thought through, organically built one on top of the other, that gives you this ability to do your sort of application be connected, occasionally connected, fully disconnected, all in one platform. Just the data naturally moves from one end to the other. From edge to edge, you're covered. That's the advantage of this data platform. And why is it built the way it is built is because of the kinds of people who have here. This is a data platform of the enterprise developer. Make no mistake about it. Why? Is because it's built by a set of enterprise developers who have done a tour of duty building operating systems, location-based services, application servers, hosted applications, mobile applications, you name it. These are all like packaged software, not just some one-offs kind of stuff. And so these developers, we know what an enterprise would demand, what type of abilities you need, scalability, performance, flexibility, extensibility, security, you name them. We know them because we demanded that of our databases when we were building those things. So that's the rigor that platform goes through in our thinking before we write the first line of code. And that's the certain amount, the no-look passes I was talking about, because this set of developers truly understand what it takes to build this one. And what this team has done here is to come up with the next set of release that will be very exciting for you, which is Couchbase Server 5.5. And we just recently released Mobile 2.0. There are some phenomenal innovations sitting here. Stuff like ANSI joins, which took more than a decade to build in the good old relation days. Here we have built it in less than a couple of years. Eventing. In the mobile end, you can do search and queries at the edge. All this makes the developer's life that much easy. It should be a joy to work with this platform, to build what you want to build, instead of just gutting it out with the trivia and the sheer management work of it, the grunt of it. That's what we all strive for. Sometimes we all sit and talk about what would be that database that we would all have liked to use when we were building those applications. That's what inspires us. That's what guides us. That's what makes us do what we do every morning when we get to work. Now, I talked to you about my personal journey at Couchbase, where I began, what inspired me to come here. And what has happened along the way is I've learned a lot. And my set of crazy developers keep me honest on that one. They make sure that I learn. And this learning has sort of given me the confidence to sort of say in front of all of you what this platform is truly capable of. It's a kind of a realized performance of what a database ought to be, based on years of building application software and system software, distributed software, mobile software. All those areas come together here. And though I continue to learn, what I'm more excited about is the possibilities that is ahead of us. the possibilities which seem even more bigger, even more impactful than what I imagined when I started at Couchbase. And the possibilities that this platform can enable for all of us. I hope, in some small measure, what we have built here inspires you to take that one step, that step which will enable you to start your own revolution. Thank you.